This is 3.3, differentiation formulas. So you're going to learn how to differentiate constant functions, power functions, polynomials, and exponential functions. So a constant function. So remember, when we're finding the derivative, we can use this formula. But what you're going to learn today are some shortcuts in finding them without having to go through the equation every time. So we want to find f of x plus h. And so, well, there's nothing to plug into, so that's going to be 5. Minus f of x, which is 5 all over h. So that's 0 over h, so that's just 0. So any constant function that you have, the derivative is always going to be 0. And that's what the first function tells us, that the derivative of a constant is equal to 0. So make sure you write that one down and remember it. Next thing we're going to look at is power functions. And we're going to find the limit of each of these. So this is going to be an x plus h minus x all over h. And this reduces to h over h, which reduces to 1. So the derivative of y to the x, or y equals x, is equal to 1. For x squared, this is going to be an x plus h squared minus an x squared all over h, which gives me in the numerator an x squared plus 2xh plus h squared minus x squared all over h cancels. Gives me 2xh plus h squared. I'm going to divide this by h. Gives me a 2x plus h. And of course, it's the limit as h goes to 0. So this is gone, so this is equal to 2x. Notice the exponent was 2. Now we're going to look at an x to the third and x to the fourth. But remember Pascal's triangle to expand binomials. So remember in class we looked at this. I'm not going to go any farther than that though. Just remember they're equal to the sum of the two above it. And those are the leading coefficients, okay? So an x to the third, we need to write down the limit as h goes to 0 of f of x plus h, so that's going to be an x plus h cubed minus x cubed all over h. So expanding the third, this is 0, 1, 2, 3. So I'm going to expand it using that. This is going to be an x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. These two are opposite, they cancel out, go away. And at the same time, I'm going to go ahead and reduce my h's so that I'm left with an 3x squared plus 3xh plus h squared, but it's the limit as h goes to 0, so these two terms are gone. I'm left that my derivative is 3x squared. So my derivative is 3x squared. See what the exponent was? All right, let's expand this last one. So it's going to be an x plus h to the fourth. It's the limit as h goes to 0, of course. Minus x to the fourth, because it's f of x all over h. Expanding that x plus h to the fourth, it's going to be an x to the fourth plus 4, see the constants up there, coefficients, x to the third h plus 6x squared h squared plus 4x h cubed plus 1h to the fourth. And then we're going to bring this down, minus x to the fourth, all over h. So these two are opposites, they cancel out. I'm going to go ahead again and reduce my h's. It gives me the limit as h goes to 0, 4x cubed plus 6x squared h plus 4x h squared plus h to the third. But the terms with the h cancel out because it's the limit as h goes to 0. And I am left with that my derivative is equal to 4x cubed. Again, it started out as an x to the fourth. See what happened? It moved in the front. So that's our power rule, is that if we are finding the derivative of a power function, and n is a positive integer, then we can take whatever the exponent is and write it in the front and just reduce the power by 1. So if I wanted to find the derivative of x to the 20th, so derivative of x to the 20th, that's going to give me 20x to the 19th. A lot easier than expanding that x to the 20th. Building off of that, we're going to now make some new derivatives from old. So taking a power function and building on there, we're going to use the constant multiple rule. I'm going to show you the rules and then we're going to work one. So it says if c is a constant, so we have this constant, and f is a differentiable function. Remember, not every function you can find the derivative of. What we can do is we just move the constant out in front and differentiate the rest of that function. So right here, the 5 is the constant, so I'm going to bring it out. And then I can differentiate the x to the 5th. So bringing down the 5, the derivative of x to the 5th is going to be 5x to the 4th. And then we just use some simple algebra and multiply 5 times 5, just simple math, 25x to the 4th. That's the derivative. So that's the constant multiple rule. Now, building a little bit more is the sum and the difference rule. So the sum rule and the difference rule is very similar, but if f and g are both functions, and we wanted to add them, then we can differentiate each function individually. And the difference rule just follows from that. It's just telling you that if you subtract or take the difference, you can differentiate each function and then subtract them. So looking at this, I want to take and find the derivative of this function. So knowing what I know now, I can take the derivative of each one individually. And oh look, here's a constant, so I'm going to put it out front. Another constant. So finding the derivative of each one of these, this is going to be a 7x to the 6th plus 5 times 3x squared minus 2 times, oh, what's the derivative of x going to be? It's just a 1. And remember what we said about the constant. If we take the derivative of constant, it's 0. So this is going to give us, right below here, 7x to the 6th plus 15x squared minus 2. That's the derivative. Now, I want to do something with this. I want to find the points on the curve where the tangent line is horizontal. So I know that if I'm talking about the tangent line, I'm talking about the slope. And so I want to know when the slope is equal to 0. So I need to actually just go ahead and take the derivative of this. It's going to be a 3x squared minus a 10x plus 6, and we don't care about that constant term. Next thing I'm going to do is I'm going to factor this, because I need to know where the tangent line is going to equal 0. So I want to know when this is equal to 0, because I want to know when the slope is equal to 0. So in order to solve this, I need to use the quadratic formula. So I'm going to do that, and I'm going to show you the answers to it. So I've solved this using the quadratic formula. I don't think I need to show you how to do that at this point. Remember, it's just as x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And so solve it gives me these two, and that would be the x coordinate. So to find the points on the curve where the tangent line is horizontal, this is the x coordinate of it. In order to find the y coordinate, what I need to do is to actually go and plug it back into here. When I do that, what I get is that the y part of it, for the point, is equal to negative 2.631. Down here, y is equal to 0.113. Now, you can graph it, and you can check it on Desmos if you would like. But you're going to have to show me how you got this. The next rule we're looking at is the product rule. And what the product rule says is that we have two functions that are differentiable. Then when we find the derivative of it, we can take the first function and multiply it by the derivative of the second, and then add the second function times the derivative of the first. So just another way to write it in the different notation so you can see it. What we have here is our two functions. Now, we could distribute and find the derivative, but I'm not going to on this one because sometimes it is harder to do that, whereas doing this would be a lot quicker and easier. So the derivative we're going to take for f of g prime, here's our first function and here's our second. So I'm just going to copy the first one, and then the derivative of the second is just going to be a 2 plus second function times the derivative of the first, 6x. And I'm going to distribute. Get and that's our derivative. Now, if you want to quickly check, if I distributed it, do it over here in black, this would have been a 6x cubed plus 6x, and so that would have been an 18x squared plus 6. So it is the same thing. I'm just showing you, forewarning, sometimes it's easier to do product rule. The next one's the quotient rule. So what it says, if both of the functions are differentiable, then we have f over g of x. Now, it's very important which one's where. Okay, we take the denominator function times the derivative of the numerator minus the numerator function times the derivative of the denominator, and then we square the denominator function. So let's try this. So the denominator function the derivative of the numerator function minus the numerator function times the derivative of the denominator function all over the denominator function squared. So doing a little simplifying, I'm going to distribute on my numerator. minus. I'm going to keep the second group in parentheses to start with. I'm going to keep the denominator as it is. Go ahead and do this. Change the signs there. And then combine like terms. There you have it. That's the derivative. Now we're going to extend the power rule just a little bit. I want you to understand that your power, though, right here that you start with, it can be any real number. So I could have actually asked you to find what is the derivative of the function f of x if f of x equals, say, x to the 3/2. And so what that would be would still same thing. You'd subtract 1 from it, and that's what you would get. That's the derivative. And then if I wanted to find the second derivative, it's going to be and it's okay if you have negative exponents. So this still works, okay? So here's just a recap of all of the functions that we used today. The derivative of constant is equal to 0. And then if you have a constant times a function, you take the constant times the derivative of that function. If you take the derivative of a variable to an exponent, put that exponent in front and reduce the exponent by 1. So your power rule. If you take the derivative of the two functions added together, you just take the derivative of each function. Subtracting, you just take the derivative of each. The product rule, it's the first times the derivative of the second plus the second times the derivative of the first. And the quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. And that's it.